Hi, a number of you have had some problems with the homework this week from I've seen on the discussion boards and through some emails regarding hierarchical clustering. I'm creating this video to explain how the process works, this particular algorithm, and how to interpret the results. What we're looking at here on my screen is the clustering results for my virtual data that I talked about previously. And if I scroll down, I'm looking at the dendrogram that was created from this. I did follow the same parameters that for your homework. I asked it to normalize data. I did 2 clusters, and I used Ward's method for the parameters. And if you scroll down, you can see here, I know a lot of you weren't sure how to interpret this dendrogram. Just make this bigger so we can see. But you can see that there are 2 basic huge clusters. One to the right over here, this one, is actually a smaller one in terms of the amount of data that's created. And you can see this down below. One of the things they ask you to look at also is the intercluster width. So you can see here the distance between 1 and 3, for instance, was 100. The distance between 17 and 28 was about, it looks like about 75. These numbers at the bottom are representing the subclusters. And remember that hierarchical clustering starts as a bottom-up approach. So it basically takes the first record, creates a cluster with that particular record, looks at the next record, tries to find the closest value to it, and go on and so forth. So then it moves up to the other levels, and that's one of the nice things about this is you can see how it's moving things together. You can see in this first cluster to the left, there's a lot of merging going on between those clusters. On the right-hand side, not as much. I know in k-means clustering, you saw my earlier videos where you were able to look at the centroids for the clusters and get a sense of, for each variable, how to describe it. XLMiner does not provide that for you in this. However, if you go to the cluster output, you'll see here the cluster ID. So you could take this data and simply split it out into cluster 1 and 2, and then do averages for each of these, and that would give you the information that you're looking for in terms of the same thing as k-means. Unfortunately, they just don't give it to you in a nice format, which I'm kind of surprised that they don't do that. You can also look at the stages, which is showing how it's going through each one of the records and how it's determining membership in each one of those records. And one of the things when you're you want to look at stability. On page 352 of your text, it talks about validating the clusters. And some of the things that you want to look at, the number of clusters, including the subclusters. This dendrogram is showing us that this first cluster is pretty heterogeneous. The second one is actually more homogeneous because it has less subclusters than the other one. You also want to look at, like I mentioned, the cluster separation is the ratio of between cluster variation to within cluster variation, which you can see here. This distance is measuring the distance in each one of those subclusters. And then again, getting the summary statistics, which they're not giving you here, but you can easily determine that for yourself to interpret, similar to k-means. The other thing you want to consider is the kind of the benefits and the limitations of hierarchical clustering. One of the nice things about it is it does start from the bottom up, so it's looking at every single record. It's doing one pass, however, whereas k-means is doing multiple passes. So it is more simple in the fact that it's doing that one pass. You are seeing all the subclusters, which gives you a nice sense of how things are being gradually merged together. You can also look at, you notice there's subcluster numbers. If you wanted to look at these subclusters, all you need to do is go over to your output. Actually, I'm sorry, under clusters. And you'll see it says cluster ID and then subcluster. So you could even do some analysis by the subclusters. If there's a particular subcluster that looked kind of interesting to you in terms of how it looks on the dendrogram, you can go and do a further analysis. But like again, you need to do that yourself. So you could make this into an Excel table. And then start looking, say I want to look at subcluster 17. I just select this, go down. And then I can add a total row on this under design. And then I can do things like average. So here I can see the cumulative GPA is 3. Total credit hours is 10.4. I could average. Looks like this is 50-50 male-female in this particular subcluster, etc. So a little more work on your part, but still able to do the same type of analysis that you did in k-means, and it also gives you more options because you're not just looking at 2 clusters. You could go down to the subcluster level if you find that that's helpful to you. So I hope this video helps you analyzing hierarchical clustering. If you have more questions, please let me know, and I'd be happy to answer them. Thank you.